Hey everyone, welcome to our solutions video for Selective Prep Mathematics, test number 46. We'll get started with an overview. I think this is the first time we're looking at this topic in our overview, and it's volume conversions. So this is like transferring or converting centimeters cubed to meters cubed, centimeters cubed to liters or milliliters. I personally found this very challenging until quite late into high school, so I just want to get everyone to understand this so no one else has the same struggles that I do. So volume conversions, the main thing about volume conversions is that you just need to remember the fundamentals, and then after that it's a piece of cake. Okay, you don't need to be memorizing every single conversion. Okay, so the fundamentals is that 1 centimeter cubed is just 1 centimeter times 1 centimeter times 1 centimeter. Okay, equals, so it's meant to say equals. Actually, get rid of that. We don't need that. So 1 centimeter cubed is just 1 centimeter times 1 centimeter times 1 centimeter. Later we'll see how that applies. And then in terms of calculating volume in liters and milliliters, 1 centimeter is just equal to 1 milliliter. Okay, so those really all you need to memorize is this point here. Now you can see the rest follows. So 1 meter cubed is just 1 meter times 1 meter times 1 meter, okay, which is going to be 100 centimeters times 100 centimeters, because a meter is 100 centimeters. So 100 centimeters cubed, so multiply by itself 3 times. So 1 meter cubed is actually 1 million centimeters cubed, not 100 centimeters cubed. Okay, so you just need to remember this this format. Okay, not each value exactly, and then you should be able to derive it on your own. And then from there, 1 liter, so one liter equals 1,000 milliliters, right? And then 1,000 milliliters is equal to 1,000 centimeters cubed. So it should say one centimeter cubed equals 1 milliliter, sorry. And then we know that 1 meter cubed is 1 million centimeters cubed. So if 1 liter is 1,000 centimeters cubed, then it's 1,000th of a meter cubed. So we have 1/1000th of a meters cubed. 1/1000th of a meters cubed is 1 liter, or 1,000 centimeters cubed. So it's pretty easy to get these units confused, which is why I'm going through this right now. Now, the next 2 slides we're going to go through is something we've looked at before. So the first is multiplying by fractions. What you want to do when you're multiplying by fractions is that you want to try and divide by the denominator first and then multiply by the numerator. Otherwise, if you multiply first, which a lot of people try and do, you're going to get a really big number that's going to be hard to divide. Whereas if you divide it first, then you're going to get a small number and it's going to be easier to multiply after that. So here's an example of what I'm talking about. So if you have 43 over 96 times 192, if you try and multiply that by 43 first, that's going to take a while. So what you want to do is divide by 96, okay? So 192 divided by 96 is 2, multiplied by the numerator after that, that's your answer, okay? It took about 10 seconds. Now, if you were to try and do it the other way, it'll take a lot longer. Okay, next, so when we have, or when we're adding up a bunch of fractions with different denominators, what we want to do is try and find a common denominator. So LCM, you might have heard it before, not that sweet bar that you might get for recess or lunch. Okay, LCM stands for lowest common denominator. Lowest common multiple. So that's what we're looking for. So we want to try and find the smallest number that every single denominator will fit into. So if we have 4 over 12, 8 over 16, 1 over 24, we want to try and make every single denominator the same. Okay, and so what we're going to do is we're going to simplify every fraction first. Okay, first step to anything is simplify. If we can simplify it, which is why we divided first in our previous slide. So 4 over 12 is going to simplify to 1 over 3, 8 over 16 is going to come half, 1 over 24 is going to stay over 1 over 24. Now the lowest common multiple here is going to be 24. So 3 fits into 24, 2 fits into 24, 24 fits into 24. Nothing small is going to work, because then 24 is not going to fit into it. Okay, if it was 1/3, 1 on 2, and then a quarter, then 12 would have been your lowest common multiple. Okay, so we want to try and make every denominator 24 here, but to do that we need to multiply top and bottom. Okay, otherwise it's going to become unbalanced. So 1/3, we're going to multiply top and bottom by 8, gives you this. Multiply top and bottom by 12, gives you this, and then leave this as is. So when you add them all up, it's going to be 21 over 24. Now, I haven't gotten rid of the annotations, but we'll go through it just like this. Shouldn't be a problem. Might even be faster. So question 1, Jennifer working on a project. So we have a cardboard box that's 12 by 12, or a cardboard square, that's 12 by 12, and we're trying to cut out 2 boards from it. So 5 by 6, one's 5 by 6, and then one's going to be 6 by 2, which is 12. So one's going to be 30, one's going to be 12. 12 times 12 is what? 12 times 12 is 144. So the total is going to be 144. The amount we use is going to be 42. So the amount used is 42 over 144. So if you divide top and bottom by 6, you should get 7 over 24. So that's how much is used. If you didn't read the question properly, that would have been your answer. But they're saying what's not used. Okay, so if it's 7 out of 24 that's used, if you minus that from 1, it's going to be 17 over 24 that's not used. Now, question 2. So if you're parking in Parramatta, okay, you have these rates that you see on the right. Okay, and so you're parking from 9:50 to 12:05, and that is 2 hours and 15 minutes. Now, 2 hours and 15 minutes, we're trying to find the minimum amount that we want to pay. And so how we can do that is, this is actually a cheaper rate than this, okay? And so what we want to do is we want to use this as much as we can. So for 2 hours, okay, 2 hours is 2 over 5 times 5, okay? So these cancel out, it's just going to give you 2. So 15 cents times 5 gives you 75 cents. Okay, that's 2 hours covered. Now we just need to look at 15 minutes, which is just 1/4 of an hour. And so that's 10 cents. So it's going to give you 75 plus 10, which is 85. That's part B. Now question 3, we have a fractions question. So she sold 2/3, which means she's got 1/3 left. That's 24. So 24, 24 left over is 1/3, which means that 2/3 is going to be 48, just double, right? So she sold 2/3, which is 48, and then 48 times 6 cents is 288 cents, or $2.88 cents. Now, question 4, we're just trying to find the area of the square. So first, let's count how many. Before we do that, I'm just going to rub this out. I'm just going to rub this out because this one's a little bit unclear if I don't do so. There you go. Sorry about that, everyone. So let's count how many full squares we have. So we have 1, 2, 3 here, 4, 5, 6, 7. So we have 7 full squares. Now we know these 2 should make a full square. These 2 should make a full square. These 2 should make a full square. These 2 should make a full square, and these 3 should make a full square. Okay, so if you just move these in, if you slot them into one square, then they'll give you 1 full square. So that's 5 more full squares, and then we have these 3 half squares. Okay, so that's going to be 1. So these 2 count as 1, and then 1.5. So that's going to be 1.5 in total. So we have 12 plus 1.5, which is 13.5. Now each square is 0.04 square units. Okay, so 13.5, or it's going to be times 0.04, or times 4 divided by 100. So 13.5 times 4 should be 54 divided by 100 should give you 0.54. Question 5 is a fractions question. So we have QRS. We're looking at Q. So Q gets 2 out of 15%. 2 out of 15 of the total profit every year. So if the share was $4,000, and that's 2 over 15, we're trying to figure out what 15 over 15 is, the total. So 2 over 15 is 4,000, 1 over 15 is 2,000, so 15 over 15 must be 2,000 times 15, 30,000. Next question. So question 6, 7, 8 I've actually skipped because they're all just using graphs, and that's pretty self-explanatory. They were all based around kind of like, okay, if you have something, so this is the x-axis, and then this is the y-axis. So they'll give you a value from the x-axis. You just link it up, okay, draw up, look up to where the line is, okay. So at 120 minutes, it'll connect here. Okay, so what's the mass at 120 minutes? Okay, it's 2,000. Okay, 2,000 grams will be completely cooked by 120 minutes. If you have 3,000 grams, how long is it going to take to cook? Okay, oh, it's going to take 170. Okay, so make sure you draw your lines properly, or you follow the line properly, because otherwise you might follow along with your eyes and then get it wrong. Okay, so that's just following along the lines to see what values we get. Now question 9, we have a rock that's put in a tank. So we have our tank looks like this. Okay, it wasn't shown too clearly, but that is our tank, and then we're trying to fill it up with water. All right, we're trying to fill it up with water, and so we put a rock in. Water level drops by 5 centimeters. So when we're calculating the capacity of the tank, it's just 65 times 40 times 80. So what I did was 40 times 80 first gives me 3,200. Okay, I got rid of the zeros. Basically what I just did is I did 65 times 32 times 100. Okay, so there's 2 zeros, which is the same as 100. So I did 65 times 32 first. This is wrong actually. So 65 times 32 should give you 2,080. Okay, and then times it by 100 gives you 208,000 centimeters cubed. Okay, and we said that 1,000 centimeters cubed equals 1 liter, so that's 208 liters. So question 10, what's the volume of the rock in centimeters cubed? So it said it dropped 5 centimeters in height, so that's 5 centimeters times 40 times 80. Okay, and so that's going to be 3,200 times 5 times 100. So 3,200, sorry, 3,200 or 32 times 100 times 5. So I did 32 times 5 first. What that gives me is 160. Okay, times it by 100 gives you 16,000 centimeters cubed. Now, question 11, this wasn't too hard. This was a bit of a problem-solving question, a bit of a basic arithmetic question. Basically, all you needed to find was, okay, we're replacing RS or PT. So what's RS? So R and S, if you follow along, should give you an R. So we can replace this with an R. So the hashtag just means where they intersect. So if you follow down here, the S and the R intersect at R. And so we can replace R-S with an R, and then the PT stays the same, so D is the correct answer. So this was a bit of a trial and error. You had to go through each one, but D would have been the correct one. And then question 12, find the value of the star. So U times V, if you look back, okay, U and then V lines up to give you Q. They intersect at Q, so we can replace that with Q, and then something times U will give you a, we don't know what it is, so something times U is going to give you question mark equals R. So Q times something equals R. So what is that something? So if we look at Q and we follow along, if we follow along, okay, Q, so we want our result to be R. So what is our question mark? It's going to be T. So the intersection, the result of the intersection is going to be R. So Q and T must intersect, which means this, so Q and T must intersect. So the question mark here is going to be T. So star times U, or star hashtag U equals T. So what times U equals T? So we look at U here and then T here. We look at U here and then T. U times something equals T. So U, look all the way down. So T is our result. So what is the intersection? It's with R. Okay. So again, U times something equals T. So U times something equals T. What is that something? It's R. So our star is equal to R. Very good. So I think that was the last question in this solutions video. And so the key points from this test, or the key takeaways, basically are volume conversions, remember the fundamentals, and then the logic follows for everything else. Okay, so you don't need to memorize everything. Fractions, simplify first and then find the LCM, and then multiplying by fractions. First you want to divide by the denominator and then multiply by the numerator after, okay, because we want to deal with small numbers if possible. Alright, so that brings our video to an end. I will see you all in the next video.